Now let us discuss reading 8 of study session 2, the probability concepts. Here we'll talk about the random variable, an event, outcome, and in events mutually exclusive and exhaustive events. Then we'll explain two main properties of probability and we'll distinguish among empirical, subjective and priori probabilities. Then we'll define in terms of odds for or against the event. We'll distinguish between conditional and unconditional probabilities. We'll look at the multiplication, addition and total probability rules. Then we learn to calculate and interpret joint probability of two events. In calculation of probability where at least one of two events will occur given the probability of each and the joint probability. Then a joint probability of any number of independent events. We'll also distinguish between independent and dependent events, and we'll look at the interpretation of total probability rule, unconditional probability, and finally we'll look at the use of conditional expectations in investment applications, and we'll look at the diagram of an investment problem using tree diagram of probability. Then there are certain other concepts which we will talk about. Calculation and interpretation of covariance and correlation. They will be useful in probability. We will look at the calculation and interpretation of covariance and correlation. Very important concepts in portfolio management. Then we'll look at the expected value, variance and standard deviation of a random variable and on the returns of portfolio. We'll look at the covariance given a joint probability function. Then interpretation of updated probability using Bayes theorem. Then identification of most appropriate method to solve a particular counting problem and solving those problems using factorial, combination or permutation notations. So let us start the probability concept. Let us look at the terminology first. The definition of probability is it is the measure of how likely an event can happen. It can be measured in percentages or fractions from 0 to 1. 0 means the event is impossible and 1 means the event is certain to happen, and between 0 and 1 there is a possibility. So what is the likelihood of the event to happen? It will be denoted by the probability. So this is the symbol PE is probability of event E, which will always lie between 0 and 1. So it could be equal to 0 or it could be equal to 1 or between them. So sum of probabilities of any set of mutually exclusive and exhaustive events is 1. So let me explain what is mutually exclusive and exhaustive event. Mutually exclusive events are which cannot happen simultaneously. For example, if we toss a coin, one outcome could be head, another outcome could be tail, but both of them cannot happen simultaneously. So they are mutually exclusive events. And the exhaustive events are all possibilities. For example, in the case of toss of the coin, there are only two possibilities, head or tail. There is no third possibility. So these two are the exhaustive event. Or if we draw a card from a set of 52 cards randomly, then there are only 52 possibilities. It could be only one of those 52 cards. So these 52 events are mutually exclusive and exhaustive. Since the card could be of only one of these 52 types. So if we try to define the event, it is anything that happens where we are trying to establish the probability. It could be a coin flip, it could be a die toss. The outcome of the event is the result. For example, when a coin is flipped, there could be two possible outcomes. One of them is obtained, either heads or tails. The random variable is a variable which is an uncertain quantity or number which stores the outcome of the random experiment. For example, the random experiment is a toss of coin. So if the variable is x, it will store the value of the outcome of the random experiment. We have already discussed mutually exclusive and exhaustive events. They will help us to calculate the value of probability for an event or a set of events. Now let us move to the next slide. Here we talk about the types of probability. First, an empirical probability. It is established by analyzing past data. For example, if we are looking at say last 50 months of the production data of a company, and we find that every month on an average there are two products out of say 10,000 products which are faulty. So based on this information we can assign a probability of a faulty product in the production. This is based on the past data. So this kind of probability is called empirical probability. Since we have calculated it based on past experiences, this is empirical probability. A priori probability is determined using a formal reasoning or inspection process. This is not based on the empirical data, but there is a formal reasoning into it. For example, we know there are 6 faces of a dice. If we throw, then the outcome will be only one of these 6. So we know the probability of getting 2 is 1 by 6, probability of getting 3 is 1 by 6, probability of getting any number is 1 by 6 because there are 6 faces of dice. So we calculate this through reasoning. It is called priori probability. The third is subjective probability. There are cases where it is not practically possible to have empirical data or a formal method. So we use a combination of personal judgments and available information to assign a probability. For example, for earthquake, we do not have sufficient historical data, or we do not have even a formal reasoning or inspection process. So based on available models and personal judgment, we assign certain probability. So clearly the empirical and priori probabilities are the objective probabilities and the other cases of subjective probability. Now let us look at the next slide. Here we define probability in terms of odds, for or against. For example, if there are odds for certain event E are say 1:3 and odds against E are 3:1. So probability of event E will be, see there are 4 cases. For 1 is for and 3 are for against. So total there are 4 cases. So probability of event E happening will be 1 divided by 4. And probability of event not happening will be 1 minus 1 by 4, which is 3 by 4. This is how we calculate probability from the odds for or against. And if we have to calculate odds from this number, then we can calculate odds for probability are probability of event E divided by 1 minus probability of E, which is probability of not happening E. Okay, So it is 1 by 4 divided by 3 by 4 and the answer is 1 by 3. Similarly, we can calculate odds against, which will be probability of event E not happening divided by probability of E happening, or 1 minus PE divided by PE. So this is equal to 3 by 4 divided by 1 by 4. It will be 3. These are the numbers which we used in the starting. So we can calculate them from each other. Odds for E is PE divided by 1 minus PE and against is 1 minus PE divided by PE. So they are inverse to each other. These are inverse. So if we look at this example, the probability of the event is given, the odds that the event will occur, this is asked. So we can simply put PE divided by 1 minus PE, that is 1 divided by 3, 1 by 3. Now let us move to the next slide. Here we are discussing conditional and unconditional probability. First, let us take unconditional probability. It is the probability of an event regardless of the other outcomes. For example, what is the probability of drawing a jack from the face card? So here the outcome is not dependent on any other event. So the probability is unconditional probability. Now let us look at the conditional probability. This is probability of event A happening given B has already occurred. So the conditional probability has been defined as probability of A occurring when B has already occurred equal to probability of A and B both of them happening simultaneously divided by probability of B happen. Let us take this example. What is the probability of drawing a red jack given that it is a jack? We know there are two red jack in the deck of cards. So assuming that B is the case where it is jack, so the probability of the card being a jack is, there are 4 jacks in the card, so it is 1 by 13, and the probability of it happening both A and B, that is it's a red and jack. There are 2 red jacks, so 2 divided by 52, that is 1 by 26. So this is PAB. So if we have to calculate conditional probability of A given B, that is probability of drawing a red jack given the card is already a jack, will be PAB, that is 1 by 26 divided by 1 by 13, that is 1 by 2. So in this case 1 by 2 is the answer. Now let us look at some other rules. First of all is the addition rule. The probability of occurring A or B, there are two events and we want to calculate the probability that either A or B occurs. So that formula is probability of A plus probability of B minus probability of both occurring simultaneously. So this has to be subtracted. So the case where we know that the events are mutually exclusive, that says they cannot happen simultaneously, so probability of A and B is 0. For that particular case, probability of A or B will be probability of A plus probability of B. For example, if we are throwing a 6-faced dice, the probability of occurrence of 2 or 4 is probability of occurring 2 plus probability of occurring 4, and we know both of them cannot occur together, they are mutually exclusive events. So probability of AB is 0 in this case. So probability of occurrence of 2 is 1 by 6, probability of occurring of 4 is 1 by 6, so our answer is 1 by 3. That is probability of occurrence of 2 or 4. Now let us move to the multiplication rule. As we have already seen from the definition of conditional probability, probability of both the events occurring simultaneously A and B is equal to probability of A given B, which is the conditional probability, multiplied by the probability of event B. This is nothing but the earlier formula of conditional probability, PAB divided by PB. And we know that if the events are independent of each other, in that case, probability of A given that B has already happened is same as probability of A, because it really does not matter whether B has already happened or not in case of independent events. Since they are independent, the conditional probability of A given B is same as probability of A. So this formula translates into probability of A and B is equal to probability of A into probability of B, simply multiplication of the two probabilities. So this is specific case for independent events. Now let us move to the next slide. It is talking about the total probability rule. If we want to calculate what is the total probability of event A, so we can calculate in a way, we are taking both the cases, probability of A while B is happening and probability of A while B is not happening. Then we'll expand these two further. So probability of A and B happening is probability of A given B has already happened divided by probability of B. This formula we have already seen in the previous slide. Similarly, when B is not happening, so probability of A given B has not happened divided by probability of B not happening. So this will be the formula to calculate the total probability of A. Similarly, if there are multiple dependencies, in addition to B, there are some other events which are related to A, C, D, E, for example. We'll have summation of all those probabilities, which will give us the total probability A. Now let us look at the another important concept, which is joint probability. We have already seen it. This is the probability of both events occurring together. This is given by the formula of conditional probability of A given B into probability of event B. So this is the joint probability of A and B. This can be rearranged to calculate the conditional probability, the same formula which we have used earlier. Let us take an example. Suppose statistician wishes to know what is the probability that number 5 will occur twice when two dice are rolled at the same time. We want to see what is the chance that 5 is occurring on both the dice. Since each die has 6 possible outcomes, the probability of 5 occurring on each die is 1 by 6. 1 by 6 for A, 1 by 6 for B. And we know that these two events are independent events. So we know the probability of A given B is same as probability of A. Since it really does not matter whether B has already happened or not, since they are independent events. So we know that joint probability in this case is going to be PA into PB. Just the multiplication of the two. As we have seen in the multiplication rule, for independent events, it will be simply the multiplication of two probabilities. So here the joint probability is 1 by 6 into 1 by 6, which is 0.0277. So this is the probability that a 5 will be rolled on both dice at the same time. So this was the basic idea about the joint probability. Now let us look at a few other concepts. The probability that at least one of the events will occur. So this is coming from the additional rule. The idea of at least one is A or B. Either A occurs or B or both of them. So there are three cases included in at least one case. So for example, there are two coins which we are tossing. So we are talking about the case that we want at least one head. So it could be head, tails, tails, heads, or heads, heads. So there are three cases. So from addition rule we know that probability of A or B is equal to probability of A plus probability of B minus probability of A and B, joint probability. So let us take one more example. A single card is chosen at random from a deck of 52 cards. What is the probability of choosing a king or club? In this case, we know that king and club are not mutually exclusive. A card could be king and club at the same time. So we know the probability of being a king is there are 4 kings divided by 52. So it is 1 by 13. While probability of being a club, there are 13 cards of club. So it is 1 by 4. While we know the joint probability of king and club both happening simultaneously is 1 by 52. There is one card which is both king and club. So the joint probability is 1 by 52. This we already know. So if we have to calculate the probability of either or case, either king or club, we need to use this formula PA plus PB minus PAB. So it is 4 by 52, that is from here, 13 by 52, that is from here, and 1 by 52, which is king and club. So finally the answer is 4 by 13. Now let us move to the next slide. Here we look at joint probability of independent events. So what are independent and dependent events? The dependent events are the ones where probability of occurrence of one event is dependent on the previous event. For example, if we have a deck of cards, we have taken one card from it and we have not replaced it back in the deck, and now we are planning to draw second card from the deck. So the possibility of second card being a particular one is dependent on the previous card because it is not part of deck anymore. So this is the case of dependent events. In the same example, if we put the card back into the deck, then the probability of second card being a particular one is independent of the previous card, since it has already been put into the deck once again. So the events are independent of each other. Probability of occurrence of one event is not related to the occurrence of the second event. For example, if we are tossing coin consecutively, so the second toss of the coin is completely independent of the first one. So probability of A given B, the conditional probability is same as the probability of A, or even for the case of B given A is same as probability of B. This we have already discussed. So now let us move to the next slide. We are talking about unconditional probability using the total probability rule, which we have studied in the previous slide. For example, in this example, there are two events. One is price rise, another is inflation. So there are two possibilities. The inflation can happen when the price rise is already there, or inflation can happen when price rise is not there. So the probability of rise in prices is given, which is 0.3. So we can calculate the probability of no price rise, which is 1 minus 0.3, which is 0.7. Now the conditional probability of inflation given the price rise is given as 0.6. So the case where price rise is already there, the possibility of inflation is 0.6, and the case where there is no price rise, in those cases the possibility of inflation is 0.2. This is conditional probability. So these two values are given. Now considering that these are the only two cases, what should be the probability of inflation? Which is unconditional probability of inflation. So since we are using total probability rule, we are covering all the cases. So Pi is equal to probability of inflation given rise into probability of rise plus probability of inflation given there is no price rise into probability of no price rise. So we have all these values. I given R is 0.6, probability of R rise in prices is 0.3, probability of inflation given no price rise is 0.2, and probability of no price rise is 0.7. So if we calculate, we get 0.32, which is the unconditional probability of inflation. It's coming from the total probability rule. So this is how we can calculate for any event the unconditional probability given that all related cases are given. So now let us move to the next topic, which is the investment tree. So through the investment tree we can see the calculation of unconditional probability. The first case is for economy. There are three cases. The economy could be poor, it could be normal, or it could be good. There are only three cases given here. The probability is 40% for the poor, 40% for the normal, and 10% for the good economy. Now there is conditional probability. When economy is poor, this is already given. What is the increase in rates? So I given poor economy. So the probability is 0.2 or 20%. And given the economy is poor, the possibility of no increase in interest rate is 80%. Similarly, given the economy is normal, so conditional probability of increase in rate is 40%. Probability of increase in rate given normal economy is 40%. Similarly, for good economy, the probability is given for increase in rates given the economy is good. Now we can calculate the joint probability based on these two values. So here we can clearly see Pi given poor economy into probability of poor economy is 0.4 into 0.2, which is 8%. That is what is the joint probability of poor economy and increase in interest rates. Similarly, normal economy and rate increase is 16%, and good economy and rate similarly, the good economy and rate increase, the probability is 8%. It is the multiplication of the conditional probability I given good economy into probability of good economy, that is 0.1 into 0.8 is 8%. So if we have to calculate the unconditional probability of a rate in rise, so if we have to calculate the unconditional probability of rise in interest rates, we have to sum these values up, but we need to be careful that all the cases are not taken. In the case of economy, it could be poor, normal, good, and there is one another case of 10% probability which is not given here. So we need to know that value as well in order to find out the unconditional probability of rise in interest rates. So this was the broad idea of investment tree using unconditional, conditional, and joint probabilities. Now let us move to the next topic,